So what we're doing here is torque tension testing with Ultrasonics. So this is actually reading torque angle and clamp load all at once. There's a little pin inside this socket that's reading the clamp load with the ultrasonic signal bouncing to the end of the bolt and coming back. So it's measuring that time of flight and converting that into load. What this is really good for is if customers are having issues with screws breaking or coming loose, we can help them diagnose what the issue is. In this specific case, we're actually just helping confirm that they're getting the clamp load that they want to be getting. With this, we actually have the ability to basically see inside the joint without making any changes, where in the past we'd use something like load cell washers, which basically looked like a really thick washer that you had to stick inside this joint. So you'd have to either cut something out or add some spacers and make the joint a little different, which is going to change how the joint reacts and give you a different clamp load. So this is really nice. Without changing anything in the joint, we can see the actual load that they'd be getting when they torque it up on the line and send these out as a finished product. So we can go ahead and run one here. So we just took this one to failure. With this technology, we can go on here and we can pull any point on that graph that we recorded. We can actually also calculate the yield point. So then from that, a lot of people base their tightening torques off of a percentage of yield. So that's really beneficial for customers to see where the bolts are actually yielding. Then we also do kind of a diagnosis, see what actually breaks in the joint when we're doing this. So in this case, you can see the bolt failed, which is what we like to see. You always want your nut to be stronger than the bolt so that it's an immediate failure, not a delayed failure. So this is a good failure, I guess we could say.